everybody who is watching this video. I would like to welcome you. My name is Olenjolai Losingo from beautiful country, United Republic of Tanzania, or in short we call it TANZANIA. I would like to welcome briefly onto our online schools, which is called Tanzania Online Advanced Secondary School, OLENJOLAIM. In these schools, actually, that we have 3 departments where we are teaching A-level students or advanced level students, and that's why we have written that this is Form 5, and also we are teaching Form 6, Advanced Physics, Advanced Chemistry, Advanced Mathematics, and Advanced and Basic Applied Mathematics. So we have a lot of information that we like every student to be aware on about what we are doing. And then you have to make sure that you watch another session which has been written at session 00, where we've given you detailed introductions. If you are watching this video for the first time, maybe you met with this video as your first video, then just go into our YouTube channel. It's called Tanzania Online A-Level Secondary Schools in square bracket OLENJOLAIM. But I would like just to remind you the vision that we have, because that is very important. Okay, the vision we have here, we want to incubate or prepare students who have a fresh mindset, who can take the classroom instructions and then solve real-life problems. So for instance, today we are going to teach you in departments of advanced chemistry, the subject advanced chemistry, we are going to teach you about organic chemistry. So from the beginnings of these sessions to the end, you have to think that how you can take these instructions and solve real-life problems. That's your business, and don't think that in one sessions you can answer that question. But every time you have to ask yourself, when you are learning these programs, where can I apply these informations or this knowledge in order to solve a real life problems? Because you are born to solve a problem or problems, right? So that is the visions of these programs. Again, we used to prepare, we say that in many educational programs in Tanzania and even some other countries, they may focus on preparing students to pass exams. Okay? That's happened, especially that in the third world countries, and that I'm speaking about the truth. In this program, or in Tanzania Tanzania Online Advanced Secondary School, we are trying our level best and will be pouring out ourselves to prepare. Yes, preparation to prepare students to pass for the exam will be a subset. It means it will be a part of our program. But our main objective in this program to see our students as successful in real life. So how are they going to be successful? In case they solve a real life problems, success is guaranteed. In case you want too much about what I'm saying, make sure that you watch session 00 or session 01, where I spend an hour to explain briefly what is in my mind. So that's what in my mind as a teacher that I'm going to teach you. I would like also even yourself to have something in your mind so you can do something great, right? Okay, so let us come to the session. So subject advanced chemistry, I believe that you are well prepared. But in every session, we recommend you to have at least a syllabus beside you, right? So that you can watch everything that's going around. Syllabus book, because you bought this one in order to use it. You didn't buy it in order to leave it in your bag and look and visit it or check it just not often, or you check it yes, sometimes. No. In case you don't have this syllabus book, you can go to the descriptions of this video and you'll see that how much does it cost you. We can sell it to you in United Republic of Tanzania and ship in any regions where you are. But again, another thing which we recommend, at least you should have 2 to 3 textbooks as a reference books, right? So you may be going through and then you have to check about what's going on. And even sometimes you can open the book and see how they've explained about organic reagents, right? There's a certain vocabulary here in this book. Is it explained? So yes, you go to the table of contents and then you check, right? Make sure that you do that. Again, question and answers book, at least you have a past paper so you can see that how questions are asked, because even questions can help you to understand the concept, right? So make sure that you have this one in your hand, and you have to make sure that you strengthen your friendship with books, right? Because you decide yourself that you want to invest in education. Okay, so let us go. So today, a topic, we have a main topic called Advanced Organic Chemistry, and the topic of the day is called General Introductions of Organic Chemistry, and we are in session 2, Types of Organic Reagents. If this is session 2, it means that session 1 is already taught. So you have to make sure that you visit it in our YouTube channels that call it TANZANIA Online A-Level Secondary School, in square bracket OLENJOLAIM. You have to watch session 01A and session 01B, right? So you can get the previous information before this session. I believe that we're going to do that. Insist you, in case that you have Thanksgiving, you can send through the telephone number and it will be accepted. So let us begin with quick review of what we have done, because I want to link this session with what. So quick review of lecture 01, right? So you have to link this session 2 with session 1, because that's how we used to learn. The first fact that I've presented to you, I presented to you about topics, 9 topics, 9 topics of what? Advanced Organic Chemistry, right? The first one is called what? General Introductions of Organic Chemistry, right? Second one is called what? Aliphatic hydrocarbons. Third one is called what? Aromatic hydrocarbons. Fourth is called what? Hydroxyl compounds. Fifth is called what? Carbonyl compounds. Seventh is called what? Halogens derivatives of 40 hydrocarbons. Eighth is called what? Seventh, carboxylic acids and what? Its derivatives. You are allowed to speak, because I'll let just remind you, yesterday I gave you a promise that I have some guest students who will introduce themselves. So tomorrow they introduce themselves, but you can hear their voice, so be familiar. Those are the students, not robots. Just because even robots, so sometimes they can make a sound. However, that you cannot see them frequently, but expect them, because they want to learn the beauty of organic chemistry. So carboxylic acid and its derivatives, right? And then the 8th one is called what? Amines, which is for the form 6, and the last one is called what? Polymer. So you have 9 topics in the main topic of 40, Advanced Organic Chemistry. And I gave you a promise that I have to pray for you, and you have to pray for me, so that we can keep this business, regardless of which field you want to study at university. As long as you're gonna study a field which may be based on biology or agriculture, or based in chemistry, you will find organic chemistry for the rest of your life, right? So here we mentioned the 9 organic, 9 topics, right? And then another thing which I began to present to you, I presented about contents or subtopics of the first chapter, which is what? General Introduction of Organic Chemistry, right? And then in the general introductions, first of all, we define what the meanings of organic chemistry. How many definitions did I give you? 3. How many do you remember right now? Possibly you remember none of them. Just got the session 01. Get too much details about this one. Again, this is one of the terminologies. So we say that we have some of the terminology in organic chemistry. The second terminology which we discussed is what? Hydrocarbon, right? So we defined what the meanings of hydrocarbon, and also I told you about types of types of hydrocarbons, right? Types of hydrocarbons. But again, in each perspective, for example, in organic chemistry, we talked about examples, right? Because whenever we define the terms, we provide some examples. So this one we did it for organic chemistry, example of organic compounds, and also we did it for hydrocarbons, and even we did it also in this part of types of hydrocarbons. Then I left 3 questions for the homework 01. First one, Mention 10 examples of 40 aliphatic hydrocarbons excluding what? Mine, right? The one that I've mentioned. Then the second questions I ask you that you have to mention 10 examples of 40 aromatic hydrocarbons excluding mine. And now the last two questions explain briefly about what? Cyclic hydrocarbons. Did you do it? Please submit the homework in the comment section. So comment section, I'm waiting. No one, at this moment, no any student that has submitted in the comment section. So you have to learn how you can type by using your mobile phone, and even how you can type by using your computer, because you are always typing SMS. So you are expert on typing something which does not relating with what? Studies. But in case of studies, you see that it's wasted of time. How you can draw, if in case that you have to draw, you have to learn. That's what we call basic computer, which I'm sure that you've been learning during your education. So today, so that is all about yesterday. We built a strong foundation of organic chemistry. So let me take you further, and I would like to teach you today about types of organic reagents. So here I made a mistake. I repeated the same way that reagents, possibly asking questions. Types of organic reagents or reactants. Or what? Reactants. So we are going to learn about organic reactants and organic reagents. So before even we define and I mention and I present to you, I have a piece of information. So we say that with respect to organic reaction. Organic reactions. You know a lot about inorganic reactions. We know that. Okay, but we want to induce new concepts on top of that. Organic reactions. We say that a compound. Okay, a compound is considered. Is what? Is considered. Right? A compound is considered, okay? Considered to be a reactor, to be reactants, or compounds is to be reactant, to be a reactant. This is R, to be reactant, to be reactant. If that's the condition, if that compound it is chemical reactive. It is chemical reactive. If you do remember that, what we insisted you yesterday, we insisted you about the big boy who called the carbon. Okay? Big boy who's called what? Carbon. So it's respected to organic compound, organic reactions. A compound is considered to be reactant if, right? If it is chemical reactive. So it means that and can take part in chemical reaction. That's the first condition. And it can take part, right, in the organic reaction. So I will be using this abbreviation. Okay? So we have two conditions, right? So two conditions are required. So two conditions. The first one, we say that a compound should be chemically reactive. Should be chemically reactive. And the second condition, we say that a compound should take part in the organic reaction. Should take part in organic reaction. So those are the two conditions for a compound to be considered as a reactant. Right? So here we have also, okay. And then the question which comes in our mind, right? How does a compound, okay, how does a compound, okay, act as what? As organic reactant. as organic reactant? That's the question. Well, so he said that any organic reactant, so any organic reactant is an organic reactant, okay? An organic reactant can take part in the chemical reaction, right? In the chemical reaction, right? By either supplying electrons, by either supplying electrons or receiving what? An electron. Receiving what? An electron. So those are the other two conditions, or the condition required for it, for an organic compound to act as organic reactant. So it should be it means an organic reactant should either supply electron or receive what? Electron. Whether 1 electrons or 2 electrons or 3 electrons. That's the conditions which are required. Either to supply or to receive. So here, to summarize, means that there's a two conditions. Okay? To supply means to donate, supply, or sometimes in case to say that donate 30 electron. Or the second conditions we say that or to receive what? Electron. Those are the factors required for an organic reactant to take part in the chemical reaction, because that's the second condition for it, for a compound to be organic reactants. You have to get prepared to enjoy the beauty of organic chemistry, especially advanced organic chemistry. So because the title is called the types of organic reactants, this is a simple introduction. So if you want to write the subtitle of what I have written there, this is simple introductions of types of organic reactants, the condition required. So because the title is about types of organic reactant, and I want to take you there, right? Types of organic reactants. Say organic reactants, because you should say it to write in your mind. Organic reactants or reagents, right? Or reagents. So we say that there are only three types of organic reactants. 3 types of organic reactants that are, okay, number 1, we have organic reactants we call it nucleophile. So in case that you find I'm teaching quickly, this is the beauty of the video, because you can review this video several times as well as you can. So you have nucleophile reagent or nucleophile reactant, and you have electrophile reagent or electrophile reactants. And the third one is called the free radical. So remember that. So this is nucleophile reagents or nucleophile reactant. You can call this one electrophile reagents or electrophile reactants. And the other ones you can call it free radical reagent or free radical reactants. Okay. So you have those 3 types of organic types of 3 types of organic reactants. So that's what we are going to study today in this lecture. Okay. And then so he said that any organic compounds. Now I want to give you a general concept. Any organic or any compound, right? Or any compound. So he said that any organic compound, because we have indicated the condition for a compound to be reactant. An organic compound, okay, an organic compound can be an organic reactant, right? So the sentence says that in compounds is considered to be chemically reactive if it is, excuse me, let me correct this. A compound, so this sentence is saying that a compound is considered as chemically reactive, right? If and only if and only if it is what? It is either nucleophile or electrophile or free radical. So any organic reactive, it should be either nucleophile or electrophile or what? Free radical. Right? Because you said that a compound is considered as chemical reactive if and only if it is either nucleophile or electrophile or free radical. Okay? That's very important. So, if that's the case, we say that any compound, say that any organic compound, because we have this question. If that's the case, do you mean that all the organic compounds are either nucleophile or electrophile or free radical? That's what you want to answer. Not all the compounds are either nucleophile or electrophile or what? Free radical. But there are the conditions. The conditions, we say that in order for it to be considered as chemically reactive is in case if it is, we consider this is a chemical reactive organic compound, then they should obey these three conditions. They should be either electrophile or free radical or what? Nucleophile, right? So if that's the case, according to the research and the lab experiments, not all organic compounds are chemically reactive. Some of them are unreactive. And the condition for them to be unreactive is in case that if an organic compound is neither electrophile, nucleophile, or what? Free radical, right? Bear that in mind. So you say any organic compound, which is neither nucleophile, nucleophile, right? Or electrophile or free radical is considered as unreactive. It's considered as what? Unreactive chemical. It's considered as unreactive what? Chemical. So an organic compound which is neither nucleophile nor electrophile nor free radical is considered as what? Unreactive chemical or unreactive compound. So you know now the conditions of types of organic reagents that we are learning in this part, in this subtopic. So now let us begin to break down each. Let us learn this is a new terminology for you, it's a new vocabulary. Nucleophile. Say nucleophile. Write this information in your mind. Nucleophile, or in organic reactions, we'll be using this symbol, it's negative. We are building the foundation for all the 9 topics of organic chemistry. Say nucleophile. Again, repeat it is nucleophile. Say again with power, nucleophile. Say nucleophile. Again, say nucleophile. Right in your mind. You have to keep it for the rest of the, because later on, we don't have enough time to explain to you what is nucleophile. Right? So before we define the term nucleophile, we say that, let me give you a brief introduction. We say the term or the word nucleophile, right, is the word nucleophile is derived from these two words. Why are we saying this in advance? Because these two words, if we break the word itself into two words, then you can remember the definition of nucleophile by remembering the meanings of the two words that joined it together to form nucleophile. So what are those two words? The first one is the word nucleo. The word nucleo, say nucleo. So this is the first way, right? And then, so what does it mean? The word nucleo means nucleus. Okay? Or come from, means what? Nucleus. Nucleus of what? Nucleus of an atom, right? Nucleus of an atom. We don't have nucleus of what? Of a mango. We have nucleus of an atom. Just that the mangoes contains atoms, then we can find nucleus in an atom, right? And that's so called nucleo, at the first way. And the second way is called what? Phile. Say phile. Phile, comes from, okay? So this is come from the word, come from the word love. I'm not sure about which language is this. Okay? Which language is this? I think it's Latin, if I'm not, whether it's Latin or Greek language, because those are the great inventors and those are the earliest scientists. This is all contributions from European continent. We really appreciate what are the previous scientists did and contributed in the world of today. Okay? So nucleo means what? Nucleus, right? Phile means what? Love. Okay. So, if phile means love, can you call your firstborn phile? I don't know. It's your decision. So, what does it mean? So, it means that the word nucleophile now, to break down, before even we go for the definition, we want to write this information online. The word nucleophile is made by two words, nucleo. So for example, nucleo, this is nucleo, so nucleo, plus another word which is called what? Phile. So so it means that now, according to that description, means that nucleophile means that it loves what? It loves nucleus. Nucleus of what? Nucleus of an atom. Oh, okay. We have to go back to our fundamental chemistry. Right? Nucleus of an atom. Have you ever heard about nucleus of an atom? Yes. What does it contain? Nucleus of an atom, this one contain, before even we define what is the meanings of nucleophile, I want you to understand. Nucleus of an atom contain two pieces of information. Nucleus, say nucleus. So nucleus of an atom contains two things. First, proton, right? And also, what? Neutron. So proton, this is positive charge. Neutron, this is neutral. Right? Okay. So nucleophile love what? Nucleus. Does that nucleophile love proton in the nucleus? Or does it love neutron? That's the question. So from the fundamental law of electrostatic, we used to say that like charge repel, and like charge attract each other. Aha! So now we have a concept here, okay? So something means that the negative charge always love what? The positive charge. And the positive charge always love what? The negative charge. Oh, that's the meaning of what? Unlike charge attracting to each other. Okay, and then that fundamental of electrostatic state that like charge repel to each other. So if I have a positive charge and there's another positive charge here, there is no love. Right? Okay. Aha. So it means that from that concept now, so it means that the nucleophile now, before even we define, I want you to understand this one. Tell in your mind, tell yourself, say yourself that understanding is coming, understanding is coming, understanding is coming. Okay, nucleophile, it means that, okay, these love sorting protons, but these protons in the nucleus of what? Of an atom. Oh, so from this fact, if love protons and you say that protons are positive charged, it means a nucleophile is what? Is a negative charge. Right? That's all you know the charge of the nucleophile. Oh, have you ever learned about nucleophile? Yes, you know them. Have you ever learned about negative charged atom or compounds? Yes. For example, when chlorine gain 1 electrons, you become chlorine ion. That is nucleophile. So you know nucleophile in your life, but you haven't been told that this is nucleophile. We are insisting and break down this concept because we know you have never heard about this information during ordinary secondary education for those who are studying from Tanzania. So that's why I might spend many examples, different teaching aids, different teaching styles, to make sure that I write this information in your mind for the rest of your life so that you can navigate well. The next topic should be simple if you understand this one. However, that there are some troubles but will be minor. Because if you mention nucleophile, you know in detail. Okay, so last protons in the nucleus of what? Of an atom. Now, okay, fine. So now we can come. If you understood, ask yourself this question and write the answer on a piece of paper. Just for a minute. Pause the video. What is nucleophile? Because many students, they just like to hear the definition, but they don't want to understand what's going on there. They want to spend their time, much time, while they are very intelligent. So what is nucleophile? So pause the video and ask yourself, even you who are in physical right now, you have to ask yourself and write on the piece of paper because this is active learning classes. So we need active student and serious student, not the ones who are ready to receive everything. You have to challenge yourself what you know. What is nucleophile? That's the question. As I know that because they are online, they might go to the Google and ask you Google, what is nucleophile? No, you have understood. If you have understood, then you have to explain, you have to write what you have understood yourself. And then I'll come and give you the correction. Right? So I'm still waiting for a moment because I want you to participate. I want you to participate actively. Okay, so I want to give you two definitions of nucleophile. Okay, so I want to give you two definitions of nucleophile. The first one, we say that a nucleophile is an organic reactant. It means that it takes place in organic reaction that provide electrons, right? Electron or electrons, right? To another reactant another reactant, which is electron deficient. Electron sorting deficient. Did you write? So check the corrections of the sentence you have written. So you say a nucleophile is an organic reactant, because you are learning types of organic reactants, right? That provide. You cannot provide what you don't have. So it's rich in what? Electrons, right? Electron or electrons to another reactant, which is electron what? Deficient. So remember that. Remember this concept here. So it means nucleophile now, this is rich in electrons. Why? Something else that we don't know, but we have again, we have another reactant, right? We have another reactant which is deficient of what? Of electrons, but it is rich with what? Protons, right? So this nucleophile provides what? Electrons. That's the meaning of this definition. Okay, I want to give you a second definition of nucleophile. Okay, remember that I'm not teaching students to cram. I don't know how to cram, and I can't teach you how to cram, but I will teach you how we can understand stuff. Oh, nucleophile, second definition. Right now, including yours, your definition, you can correct, you can mark yourself. Nucleophile is a chemical, right? You can choose either of this definition. Is a chemical species. Nucleophile is a chemical species, or is a chemical, yes, the chemical species, which is rich species, or is a chemical substance. I don't remember well the latest of species. The chemical substance, Chem, which is rich in what? In electrons. Which is rich in electrons, right? Which is rich in electrons and can donate. And it can donate. Okay, can donate. Remember that what donate, it's rich in valence electrons. Those are the ones that are taking part in covalent bond formation. Donate valence electrons. Okay? Valence electrons. This is more sounding in chemistry. The valence electron, okay, the valence electron to the another reactant, right, which is electron deficient, which is deficient of electrons. Either one electron, so the meaning of having this bracket S means can be 1 electrons, 2 electrons, depending. So this is another definition of nucleophile. We say that it's a chemical substance which is rich in electrons and can donate those valence electrons, so you have S in here, to another reactant which is deficient of 40 of electrons. So that's all. So nucleophile, and then so you have nucleophile which is rich in electrons, and then another compound or another reactant which is deficient in electrons. Well, if that's the case, let me give you a challenge. What are the examples of nucleophile now, which you have understood the lesson. So before we give you examples, I'd like to give you first the types of nucleophile used in organic chemistry. Used in organic chemistry. Types of nucleophile. Say nucleophile. Types of nucleophile. Types of nucleophile. Nucleophile. Right? So we say that in organic chemistry, there are three types of nucleophile. Three types of nucleophile that are, so in these three types of nucleophile, we'll mention examples. The first one, we call it negatively charged ion. Negatively charged ions, or we call them anions. Negatively charged ions, or what? Anions. Okay? So say negatively charged ions or anions. So simply we say that these are the nucleophiles. These are the nucleophile which reach or okay, which are in the octet state. It means that they contains all the electrons. Octet state after gaining electrons. So we say that these are nucleophiles which have been formed by gaining of electrons. So it depends. So why are they gaining electrons? First of all, they are in octet state. What the means of octet state? You have to refer what I taught you in general chemistry. I taught about octet state. Okay? So let me give you examples and then I will explain. But let me explain to you that what the means of octet state first of all, okay? And I've gained electrons. Okay? Let me take one of a common example. Okay? So now examples. So examples, we have a group of 40 halogens. So halogens elements. So you say halogens, we means about fluorine, chlorine, and bromine, even iodine, but we are not sure, but yes, in the iodine also. So these are halogen elements, and these elements are found in group 7 of periodic table of modern modern periodic table. So in case of halogens, we want just these are, for example, that when we say halogens, we mentioned that, but here they are not. These are halogens atoms, right? Halogen sorting atoms. So we have halogens atoms. So we want to explain to you, and then we'll give you examples, which is halogens ions, because we say negatively charged ions. So for example, let us take for fluorine, the atomic number of fluorine is 9, right? And then if we write the oldest O-level electronic configuration, then you can write at 2 and then you have 7. What does it state? This is inner shell, this is outer shell. And here, fluorine contains 7 electrons in the outer shell. But this is fluorine atom, right? And we used it during our life for form 2, this is the nucleus of fluorine. We used to draw the electronic configurations in this form, right? And then here, these are inner electrons. They don't take part in formation of covalent bond. And then you have 7 electrons. Remember that this cause I'm going to teach you from the fundamental idea. So even sometimes if you forget some of the stuff, I might spend short time to remind you. Just like this. This is knowledge of Form 2, right? It's better if I give you the quick review, even if I'll be talking about other remaining elements of halogens, you get the picture. But for advanced electronic configuration of fluorine, this is right that this is 1s square, and then 2s square, and then 2p, what? So these are 4, so 9 minus 4 is equal to what? 5. Right? So this is the second method of writing electronic configuration. So we can say that now, including the octet elements, this is helium, because this is electronic configuration of helium. It's inner shell, so these are the 2 electrons, right, if you relate. And then so you have again 2s squared, 2p, 5. Right? Okay. If you use orbital method, then this is the first, the inner shell, okay, inner orbit. And then this the another guy, right? So you have this guy, this guy. So according to the principles of filling electrons, we say that each orbital should be filled with 1 electrons before pairing. So 1, 2, 3. Here we have what? 5, right? So we begin pairing from this orbit and this guy, right? Okay. So we have 1 unpaired electrons. And this is the one, this is the orbit, an orbit, it's only an orbit which is not in octet state, which is missing 1 electrons, right? So what happens? So now if we ionize fluorine by following the procedures of thermochemistry, where we used to give fluorine, or we bombarded fluorine with a particular type of energy which we call electron affinity.